winter break for 8th grade physics, the most common mistake kids make is with these stacked body friction problems. It involves force analysis using the whole system method, which many kids haven't mastered. In today's video, teacher Yaiwen will show you how to conquer it. After watching, take this 8th grade physics mechanics summary and friction practice sheet for your child to work on. It covers all the essential exam questions for this section. After finishing, they'll easily get a perfect score when school starts. Parents who don't have it yet, hurry and print it out for your kids. Now, let's take a look. The gravity of A, B, and C is 1 Newton each, and the horizontal force F is 5 newtons. All three are stationary. Now it asks, what is the friction force of A on B in newtons? To analyze this, first focus on the motion of the objects. Remember, force analysis is not about looking at forces in isolation, but rather combining it with the motion state. It's currently stationary, all three are stationary, so it's in a state of equilibrium, right? In equilibrium, the forces are naturally balanced, acting as balanced forces. Therefore, no matter who we analyze, whether as a whole or in isolation, the final forces drawn must satisfy equilibrium. Now let's look at the friction of A on B. On which surface does this friction occur? Isn't it this surface? For these kinds of problems, there's actually a little trick I can teach you. It's called finding friction by treating everything above the surface as a whole. Treating the surface as a whole to find friction. What does that mean? Since multiple objects are involved, the biggest difficulty for many kids is identifying exactly which object to use as the subject for force analysis. So, this phrase actually gives you a clear guide for finding the subject. First, locate them, the surface it's asking for. For example, for the friction of A on B, where is that surface? It's right here. Then treat all objects above this surface as a single whole and perform force analysis on it. This is the basic method and approach. Okay, once we've found this surface, we draw a line here. See? What's above it? Isn't it just object A? So we only need to perform force analysis on A. Now, in the vertical direction, A is subject to downward gravity and an upward normal force. Since it only feels these two forces, they must be balanced. Okay, what about the horizontal direction? Well, many kids might think, since F is pushing B, won't B also rub against A as it moves forward? Now just suppose, that B exerts a friction force on A. Let's use the method of hypothesis. Based on the equilibrium we just discussed, there must be a force in the horizontal direction to cancel out that friction. But can we find such a force? Look, if B gives A friction, is there anyone else giving A another force to cancel it out? No, right? Therefore, this friction force cannot exist. If it did, these three forces could never be in equilibrium. So what is the magnitude of the friction between A and B? It's 0 newtons. Okay, moving on. Finally, it asks for the number of forces acting on object C. This is essentially just force analysis on C. We first need to determine if C has friction on both its top and bottom surfaces. Okay, let's use the same method as before. First, let's analyze its top surface. Is there friction there? To examine this surface, we draw another line across it, right? We treat all objects above the surface as a single whole. That means taking A and B together. Consider it as a whole. This large whole is subjected to, let's draw it at the center of gravity, a forward pushing force F, and then a backward friction force so that it can balance with the pushing force. So if the pushing force is 5 newtons, the backward friction force should also be 5 newtons. So who provides this friction to this small AB hole? Is it the friction force of C on B? This is the friction force of C on B. Well, since C exerts it on B, then conversely, B also exerts it on C. So the upper surface of C will definitely be subjected to a friction force. And the magnitude is 5 newtons. Next, let's analyze the friction from the ground. Come on, for this ground friction force, we should use the ground as the cutoff point, right? Draw a line here and consider all the objects above as a whole. That would be these 3 objects, A, B, and C. Let's draw a big box and enclose the 3 of them. Now this whole of 3 is subjected to a rightward pushing force of 5 newtons in the horizontal direction, so the bottom surface must be subjected to a friction force in the opposite direction. This friction force is the friction from the ground on C, which occurs on this surface. Its magnitude should also be 5 newtons. So it's settled. The bottom surface also experiences 5 newtons of friction directed to the left. Okay, now let's draw the final free body diagram for C. Combining the previous research, shouldn't object C be subjected to a vertically downward gravitational force GC? And secondly, it's being pressed by B from above. Don't forget, B will also exert a vertically downward pressure on it. Pressure from B, then won't the ground also provide it with a vertically upward support force? See, I found all the elastic forces this way. First gravity, second elastic forces. For elastic forces, just look for contacting objects. Okay, friction. We just analyzed which way the friction on the upper surface of C is. Isn't it subjected to rightward friction? So this is from B to C. The rightward friction force of B on C equals 5 newtons, and conversely the ground will give it a leftward friction. The F from the ground to C also equals 5 newtons. Okay, all forces are analyzed. Count them: 1, 2, 3, 4, 5. C is subjected to a total of 5 forces. Got it?